Hey you folks, Quilly18 here, and welcome to a brand new episode of our multiplayer first-person shooter tutorial, and also kind of a mini tutorial on bots and artificial intelligence enemies for first-person shooters. What we're going to do over the course of the next probably 2 episodes is implement a very simple bot, an enemy that will walk between waypoints and shoot at enemy players that come by. Obviously not going to be very sophisticated, but good enough for 99% of what you're actually going to want to do in most games. This is not going to be an enemy that resembles, say, a player's performance, but is going to be a good sort of standard kind of monster in these sorts of games. So to start off with, what we're going to do is we're going to make changes to our existing setup, because so far our existing setup assumes that all the sort of characters in the game are human players that are controlled by an actual human being with a mouse and keyboard. That is no longer going to be the case. Now our characters might be controlled by an actual player or might be controlled by some sort of AI. So we're going to make a couple of changes. Basically to 2 scripts to start off with. It's going to be the player movement script and the network character script. So we're going to start off with the player movement script, which should already be open, right over here. So in here, let's review what this script does. It does, well, basically 2 things. In the update function, which runs every frame, we take in the player's inputs. We check to see, based on the axis, vertical, horizontal, which is basically mapped to, say, the WASD keys on the keyboard, for example. We find out where the player wants to move, how he wants to move. So that's the direction vector over here. We also make some adjustments to our animation that toggles between running and walking and idle, for example. I guess we don't have a walk versus run blend, but idle to run is what we've got going on here. And we also check to see if the character wants to jump. And then if we do want to jump, we set the vertical velocity to that. We also make a change to the aim angle, which just modifies our animation of sort of leaning backwards and forwards, which is not very good, but it is there. Then we have, in the fixed update function, we actually process the movement. So the reason we have a split between update and fixed update is because update runs every single frame, and for things like get key down, get key up, axis processing, it's much better to do it in update because, well, actually for things like get update and also get button, it doesn't really matter where you do it, but if you ever use the get button down or get button up, which responds if a button was pushed down or released this frame, it is in this version of the frame. Whereas fixed update doesn't operate in every frame, not every FPS, not every frame per second. It instead operates on every tick of the physics engine, which is why we're actually doing our movement here, because the physics engine will sort of behave better in general if all your movements are done within fixed update, and it can sort of predict a little bit more reasonably where everything is. Anyway, enough of a revisiting then. So the big thing is, in update, we set our direction, and in fixed update, we use the direction and also the vertical velocity to affect movement on the character. So this is all in player movement, and we don't really need this to necessarily be here. If player movement's job is to read input and output from our human player, and we're ultimately going to want another script for artificial intelligence characters, I'm wondering if you're picking up what I'm putting down here, which is to say this fixed update should be identical for both players and AIs. The thing that will differ is this. On a player character, we are reading inputs and outputs, and on an AI character, instead what we're going to do is make AI decisions and set our direction from there. So what we're going to want to do is basically split this in 2. Now, it so happens we have a network character script. Now, it's easy to imagine that all characters in the game, human or otherwise, are going to have this network character script on them, because all characters in the game are going to need to be synced over the network. This is responsible for updating positions and all that sort of stuff. You'll notice we have the update over here, which moves the character sort of physically in the game based on what information we're getting in and out of the network. Now, it's, I think, very easy to imagine. Well, a couple things. First of all, I think that we want to change this from update to fixed update. I think this may have made a mistake the first time around, because, again, we want to try to move all of our characters within the physics time step, not within the visual time step. That way it ensures that everything is, happy, hunky-dory, like so. So let's go ahead and make that change first. Well, I guess I can leave that. We'll leave the note in. Actually, I'll just grab the note from fixed update over here. Right? Fixed update is called once per physical loop. Do all movement and other physics stuff here. Now, if the photon view belongs to us, we're not doing anything, right? Right now, in the network character, we're not doing anything here because this is our local character, And so we don't want to change our local character's position based on network inputs. We want to change it based on, well, currently player inputs. What if we took this fixed update code over here? If we took all of this and moved it into network character. That way, all network characters, whether they're player character or AI characters, would then have the same code on them to actually implement movement. That sounds good to me. That's exactly what we want to do. We want to change everything that has to do with actually implementing character movement. We want to move into network character. And then player movement will actually just deal with getting the input and output from the player and then feeding it into network character from there. So I'm actually going to take this whole function. Okay, I'll even take the comments. I'm going to grab this whole thing. I'm just going to cut it out, move to network character, put in a space right over here, and paste it in. Now, obviously, right now, it's still called fixed update. We'd have two fixed updates in here. We don't want that. We want to do something like, what if we call it do local movement? Okay, get rid of the comments. And in every fixed update, if the photon view belongs to us, we will do local movement. If it doesn't belong to us, then we're just reading the position off the network and going from there. I think that's pretty good. I think that's exactly the sort of thing that we want to do. Now, you'll notice right away we get some things highlighted in red because these are member variables that don't exist in network character. They only exist in player movement. So we're going to have to get these recreated, which is fine. Direction and speed. You know what? These are, some of them are bookkeeping variables. Some of them are public attributes. For example, speed and jump speed. The player movement, if this script is only responsible, now we can update the comments for this. This component is only enabled for my player, i.e. the character belonging to the local client machine. And we will say something like, this script is responsible for reading input commands from the player and then passing that info to network character, which is responsible for actually moving things. So, speed and jump speed, our player movement script doesn't need to know this information. Doesn't need to care. It doesn't care how fast our character is supposed to move. That's not something that it needs to know. However, a network character should know that. Now, note, only our local character will effectively use this. Remote characters will just give us absolute positions. Right? These two variables down here will only really be used by our do local movement script. All right, so that's speed, and direction is still in red. Okay, well, let's talk about direction. Direction is a bookkeeping variable over here, where our player input is feeding our direction over here. Well, here's a question. Do we want that to still be here? Well, consider this. Our artificial intelligence script will also want to be able to assign a direction. And then the direction will then get fed into network character during the do local movement. So that sounds like another good candidate for moving into network character, as well as vertical speed. Okay, let's grab both of these. Did I call those booking variables as opposed to bookkeeping variables? Wow. Bookkeeping variables. So those are in here. Now, player movement will now have errors over here because direction is no longer a local variable. We're going to want, instead of sending it locally, we're going to want to feed that into the network character's direction. So that's fine. We can do that. Let's go ahead. In our network character, we're going to have to make this public so that we can write to it from other scripts. Now, by making this public, it does mean it's going to show up in the inspector. So if we go to our player controller, assuming I saved the change, well, it's not going to work because it's going to give us errors. But if I go to our player controller, that would mean that under here, direction would be visible. And that's not really something we need to have editable in the inspector. So we can make it public, and this is just a little trick. This is not important. This will not change anything about how your program works. But if you don't want direction to show up in the inspector, what you can do is do system.non-serialized before a variable. And that will mean that direction will no longer be listed in the inspector and won't be serialized by Unity. We can do the same thing, say, for vertical velocity, because we're going to want to be able to set vertical velocity from our player movement. Or do we? Actually, that's an excellent question. I'm not sure that we do. Because player movement shouldn't necessarily need to know what our jump speed is. All it needs to do is tell our network character, hey, we want to jump right now. Let's back up over here. Let's not make vertical velocity public, but instead, let's go ahead and make a public bool is jumping. And we'll have it default to false, and we'll have it not be serialized either. Something like that. And then in our player movement script, instead of setting vertical velocity something, we're just going to tell the network character that, hey, we want to jump right now. We'll just set it to true. Okay, now that we've done that, we need to do a few things. First of all, do we still need a copy of the character controller? I don't believe we do. I don't think player movement actually requires a copy of character controller at all anymore. So what we can do is get rid of this. Actually, I'll do some copy and paste because network character does need a copy of it. Yep. Network character needs a copy of it. So we'll put that there. And then we'll grab from our start. We'll put that in our start over here. Actually, I suppose technically that's in cache components. Right over here. We could do another safety check. If cc equals null, then debug.log error, no character controller. Like that. Okay, that's good. That gets rid of some more little missing things. In fact, we have no more missing things at all in network character. Network character should compile properly at this point. Player movement will still complain though. Now, player movement actually does need some things because, again, we don't have direction in player movement anymore. But what we can do is we can grab a copy of our network character, like this, and then get component, network character. Oh, I should make a note over here. In network character, we do this whole sort of caching of components thing. It should be noted that in Unity 4.6, we won't have to do this because get component will sort of be smart about caching components. So the first time you call this, it'll be this sort of slow call while it looks for an animator component. But on follow-up calls, it'll pull it in from like a cached memory location, just like what we're doing here and store it in the variable. So it'll actually save a little bit of effort and be very nice. So anyway, we've grabbed a copy of our network character. So then what we can do is we can now access netchar.direction. And again here, and let me grab that there, and there, and there. I could have grabbed maybe a copy of the direction instead of like keep accessing the netchar version, but we're going to be okay. Oh, we do need to know if we're grounded. Actually, no. No, we're going to be fine here. If we are currently holding down the button for jump, then what we're going to do is in our netchar, we're going to set is jumping to true. Otherwise, we'll set it to false. And then we'll deal with jumping on the other side. And then we adjust camera angle, and I think now we will compile. Now let's go see if it works. We'll hit play, we'll hit single player, we'll go red team. And yeah, I can move around again. So despite the fact that we've moved all our code to a completely different area, we can still move around. Let's try to jump. We can't jump. Now, you might think, why is that? Well, of course, when we're jumping, all we're doing right now is we're setting netchar is jumping to true or false. If we go over to the network character, we're not doing anything with that quite yet. So let's do that. In do local movement, let's make some code there. So, what are we going to do? Because we're checking is grounded, we're doing all sorts of things. We're currently on the ground and vertical velocity is not positive. We're not starting a jump. Well, what I think we're going to do is very simple. We're going to say if is jumping, Okay, if we have the command to jump, first of all, set is jumping back to false, because we only want to do the jump once. Next, if we're grounded, then set our vertical velocity to be equal to our jump speed. That's it. That's all. Now we should be able to jump again. So if we've received the command that we should be jumping, first toggle the jumping back to off. If we keep holding down the space bar, then it'll get toggled back onto true relatively soon anyway, so we can keep doing sort of bunny hopping or whatever. But so first we set it back to false, and then assuming we're actually on the ground, then we set our vertical velocity to the jump speed. That's it. And then we process the actual vertical velocity, we play the animation, we do all that sort of stuff. So now if we hit play, we should, once again, be able to jump. And it actually changes into jump animation, as we can tell from our little shadow over here. Okay. Everything is awesome again. This shouldn't affect our multiplayer in any way whatsoever, because in the multiplayer, remote things still only access or only execute this, where they adjust the position on remote stuff this way. So we are back to where we were, but what we have is a much more segregated and clean set of code, where network character handles all character movement. And we can make a more explicit note over here. This script is responsible for actually moving a character. For local characters, we read things like direction and is jumping, and then affect the character controller. For remote characters, we skip that and simply update the raw transform position based on info we received over the network. Hopefully that is clear to everyone. I'm going to cross my fingers and hope that that's true. So now that we've done that, now that we have our human players working again, let's consider what it means to have a bot. So we have our player stuff over here. Let's go ahead and make a duplicate of our player controller. So we can, it's not in the pop-up menu. That's odd. Control D on Windows or Command D on the Mac will allow you to make a duplicate of an asset. And we're going to call this one AI controller. No, maybe bot. I like that. Bot controller. This is going to be a bot. Not a very smart one, but it will be a bot. So what's the difference between a player and a bot? Well, on a player, or on a bot, we're going to remove the player movement and player shooting scripts. Again, these are both responsible for processing inputs from a human being. So we're going to remove both of those components. Note that they weren't active anyway. In fact, it is technically possible, and in fact may be desirable. Maybe we don't want separate controllers for these two things. Actually, that's a really interesting question. Maybe we don't want two controllers. Maybe we only want one controller, but we're going to have 4 components on it. Player movement, player shooting, bot movement, bot shooting, and then we just enable controllers as needed. Actually, I might like that a lot better. That was not my plan going into it, but that's pretty good. The advantage of having this as a separate resource as well is we could change models. We could have completely different character models for bots, really to emphasize the fact that they're just like kind of stupid, not very smart. Maybe literally make little robot characters, or use some sort of flame-throwing imp, or whatever kind of graphic you might be interested in doing. I suppose for the sake of argument, I'll keep them separate. The advantage of keeping them separate is I could also set different stats on the network character script here, the speed and the jump speed. I could have bots maybe move a little bit slower, for example, or different things like that. So we'll have them as separate controllers. So now that we've done that, let's get a new script on here. First of all, let's organize some of our stuff. Player stuff script should include player shooting, maybe network character should go under there as well. Yeah, I don't like this organization one bit. All right, that'll be good enough. So let's go ahead and create a new script. And we're going to call this one bot movement. And before I forget, I'm going to go ahead and drag that onto the bot controller. Really, I can't drag it on from here? Another bizarre thing. I can drag it on from here. I can't. Okay, that's strange. I know you can drag it on when you've got an instance of something. I didn't realize we couldn't drag it into prefab on a project. All right, now we have a bot movement script. So the bot movement script is really going to echo what the player movement script does, right? So first of all, in fact, we can have some of the same comments. This script is only for my bot. In other words, only the local client will have this enabled. In practice, this means the master client, which is probably responsible for spawning bots. So keep that in mind. That's very important that remote bots will have this script disabled, right? So if I create a game and I say I want 10 bots in there, those 10 bots will have the script enabled for me. And as the sort of the server or whatever you want to call it, my computer will be responsible for operating the bot AI. Anyone else who joins afterwards will see the bots, but to them, they will simply be network characters. The bot movement script will not be enabled for those people. In fact, I think it's very important that I remember to go and disable the bot controller script as a default. So I'm going to spawn bot controller on other players' screens, but the bot movement script will be disabled. Okay, that's what I'm saying. We might just want a single player controller. We're going to keep splitting these up for now, but I hope that it's very easy to imagine that one controller would be sufficient to control all things, whether they AI controlled or not. So in the player movement script, we know we need a copy of the network character. It certainly makes a lot of sense that the bot will need a copy of that as well. Sure, why not? And then we're going to go and grab a copy of it in start, just like we did in our player controller. And then all we need to do is our bot needs to have some sort of AI that, determines what it will do. How does it determine how to behave? I don't know. Let's start off really, really in a kind of a silly way of doing it. We're going to have our bot, all it does is try to jump. So every single frame, it's going to set netCharacter.isJumping to be equal to true. That's all it's going to try to do. And then we'll verify that everything is working. Okay? So we have our bot controller, we have a player controller. How do we get our bot to actually spawn? Because I'm trying to think, if we would go and start in single player mode, it might work. Let's go and find our player controller, which is over there. Let's try to drag a bot into the game world. And then enable the bot movement script. Well, there you go. Like that. Our bot is doing exactly what it's supposed to do. It's trying to jump every single frame. And I do realize our jump animation is like exceptionally poor and doesn't update properly when you land on the ground. But I am a programmer and really not an artist. And coordinating animations is still well outside of my wheelhouse. So my apologies for that. Better people than me will do a better job at that. But there we go. So we have a bot. It's an incredibly idiotic bot because all it does is jump every single frame, or every time it hits the ground. It's constantly trying to jump. It's just holding down the space bar, so every time it touches the ground, it instantly pops right back up again. All right, next episode, we are going to set up waypoints to this bot to have it walk between waypoints, and then we're going to try to get it to shoot at the players that are nearby as well, which the hard part of getting bots to shoot at players will be having the bots suck, because by default, bots have perfect aim. They can instantly turn towards you. They'll perfectly line up their shot every single time, and they can have 100% headshot hit rate. So what you have to do is you actually have to make them less good by intentionally making them stupid and slow to respond, which is kind of an interesting thing to consider. But we're going to start off with waypoints and getting this guy to walk around. See you next time, folks. Bye-bye.